by this section of the notes. It's 2.2. 2.3, regulation of blood glucose concentration. We have these two materials ready. While you slowly ease in, I'm going to do a quick recap of what we've done so far. So far, previous chapter, we were on homeostasis. The idea of homeostasis is to regulate a stable internal environment. We want to regulate the conditions in our body within a narrow range. They're safe for our body's function and survival. We know that in order to achieve this, we require receptors to be able to detect changes. Other than that, we need a control center to be able to interpret the change. Last but not least, we need effectors to be able to bring about a change so that we can counteract whatever the stimulus was. Right? That's homeostasis at work. Then we went into the next chapter, the endocrine system, which is where we are now. And really, the function of the endocrine system serves more like a communication system. It is these arrows that help to communicate between the various parts. Because the receptor and the control center and the effector may not be close to each other. And that's what hormones are for. We started off by learning about the various parts of various parts of the endocrine system. We learned that other than there being hormones, there are the endocrine glands that are responsible for secreting these hormones. And in order for these hormones to be received as a message by the effector cells, we require receptors. Last week, we learned about how the properties of hormones can affect what kind of receptors they will bind to. Yeah? And we realized that it's nothing more than application of your JH3 learning. So where are we today? Today, we're going to look at one case study. Okay? This case study helps to relate these two together. I'd like you to pay attention as we learn about this case study, what the receptors are, what the control center is, what the effector is, what's the hormone involved, right? What's the endocrine gland involved. For this particular chapter, there's only one case study you need to learn, and that case study is this one. How does our body homeostatically regulate blood glucose concentration? Have we learned about one homeostatic control within our body? In the previous chapter, we learned about the homeostatic control of temperature, thermoregulation. We learned that if temperature is too high, our body will find a way to bring it back to normal range. If it's too low, it will find a way to bring it back to normal range. Today, we're going to learn about how, if our blood glucose concentration is too high, how does our body bring it back to normal range? If it's too low, how does it bring it back to normal range? In the context of using the endocrine system. For this, we use our nervous system primarily to regulate. Okay? Some students ask, is homeostasis equals to endocrine system? What do you think? No, right? It's not. It is merely a means of communication so that we can achieve homeostasis. Can the endocrine system be used for other things other than homeostasis? Can. For example, when you see a madman running with a knife towards you, you start producing the hormone adrenaline. It's not homeostasis at work. It's just getting you hyped up so that you can run away from the assailant. Yeah. So endocrine system not necessarily always used for homeostasis. It's a means for communication. Same. For the next chapter, we're going to go into nervous system. It can be used for homeostasis. It can also be used for other means of communication. They can also be used for other purposes. For example, just me moving my arms like that required communication from my brain all the way to my hands and my arms. Yeah? But that's not homeostasis. Okay, so think of these two chapters we are learning as a means of communication. So today, we're going to look at a case study. And I want you to pay close attention to what all these parts are. For a start, we're going to come back to the pancreas. Because the pancreas is the gland that we want to focus on in this case study. Have I done this already? Last week? I felt like I dipped a little bit into it. I did, a little bit of. So we touched about the pancreas. The pancreas is our gland of focus in this particular case study. Along the way, see if you can spot the receptor, the control center. We did this? Felt like we did. We did this up. Okay, so last week, we did our course a little bit about learning about the pancreas. It's the gland of focus. And I asked you a question, can you recall what else is produced by the pancreas? The exocrine function. And the answers are amylase, protease, and lipase. What does this mean for you as a student? It means that the pancreas serves both in the exocrine as well as endocrine role. So today, we're going to focus our attention a little bit more. We're going to zoom in to the pancreas and learn about the various cells within them. More specifically, the endocrine cells that are responsible for secreting the hormones that we require. I'm not sure if you recall from your JH2 type, you learn about two hormones called insulin and glucagon. Okay, now we're going to bring that all back. It's a full circle. We're going to come back to that. Okay, this morning, I'd just like you to pay attention to the kind of cells that you can find within the pancreas. These cells are endocrine in nature. They are responsible for producing hormones. And that's where we want to focus our attention for this morning.
The pancreas. Objective: to learn the structure and functions of the human pancreas. The human pancreas is a pear-shaped gland, which is located in the back of the upper abdomen, somewhat behind and below the stomach. The head of the gland is the widest part and lies in the curve of the duodenum. The gland tapers and extends upward, ending near the spleen. The pancreas is composed of two types of tissues: the exocrine portion, which secretes digestive enzymes, and the endocrine portion, which secretes hormones. Because of its functionality in both the endocrine and digestive systems, it's referred to as a mixed gland. The exocrine portion of the pancreas secretes a pancreatic juice that contains digestive enzymes and bicarbonate. This fluid flows into the small intestine where it further breaks down carbohydrates, proteins, and lipids. Groups of distinct cells called the islets of Langerhans, named after the 19th century German pathologist Paul Langerhans, are scattered more heavily in the tail of the pancreas. The islets of Langerhans are composed of three types of cells: alpha and beta being the two primary ones, and delta being the third. In response to dropping levels of blood glucose, the alpha cells secrete the hormone glucagon. which raises blood glucose levels. The beta cells secrete the hormone insulin in response to a rising level of circulating glucose. Insulin regulates sugar metabolism and helps to maintain normal sugar levels in the blood.
Okay, we pause here for a while. Okay, you managed to gather type of cells that are present within the pancreas. I think for yourself, you have encountered 3 types of cells. Number 1, alpha. Number 2, beta. Last but not least, delta. You can omit the delta cells, that's not part of the syllabus. So let's focus on the alpha and beta cells. First and foremost, within the pancreas, we have cells called alpha cells. We also have cells called beta cells. They are often found in a collection together. And we call these collection of cells like little islands. And so they are called islets of Langerhans, because that's the name of the person that discovered it. So this little collection of cells, islets of Langerhans. Anyone studies German? Sorry, why you look there? Oh, Ife, am I pronouncing it correctly? At least from the video I gathered is Langerhans. I've been pronouncing Langerhans for a long period of time. The islets of Langerhans. But whatever floats your boat to help you remember the spelling. Yeah? Just like how for myself, I cannot spell esophagus without pronouncing it as esophagus. Yeah? Such a bad O. Okay, alpha cells and beta cells. For yourself, I think what's more important is, do you manage to capture what hormone these 2 cells produce? Manage to? It's your beta cells. Insulin, thank you. And then glucagon. Sorry. I like looking down on your glucagon. Alright. This one, what class? Next door. 403 taught me. Okay, so to help you remember, glucagon, one A secreted by alpha cells. Okay. Then the next question is, when do the alpha cells get stimulated to produce glucagon? Okay, to be able to answer this question, right, we must know its effect. So what's the effect of glucagon? Hey, actually, I don't know how good you all are. You all remember all this from JH402 time? You do, roughly? No, not really. Hey, I taught you at Isabel. From JH402 until now. Okay, so for those that didn't really catch, if I want to summarize the activity of glucagon, you're nodding your head. Jiaqi, can you summarize what's the function of glucagon?
It increases the blood glucose level by
Yeah.
increasing the risk of glycogen breakdown and glucose release by the liver.
Okay. That was a lot. It increases blood glucose level. On that note, therefore, insulin decreases blood glucose level. If you work backwards, you should be able to infer what the stimulus needs to be. What might stimulate alpha cells to produce glucagon? What might stimulate beta cells to produce insulin? Right, work backwards. Yeah. Okay, in a homeostatic system, negative feedback, work backwards, you will know what the stimulus might have been. So in order to stimulate the alpha cells, the blood glucose level needed to be low blood glucose. order to stimulate beta cells, you needed a high blood glucose level. I haven't said the questions yet. Okay. Endocrine system. Where can you find all this information? You can find the information in your textbook. It comes with a very pretty diagram I like to use for my own revision. You zoom in to the very bottom of each of the diagrams. It says low blood glucose levels, high blood glucose levels. So you can give that a highlight because it's a very small title. But it shows you the response that the body takes depending on which condition takes place. Okay, for yourself, I think it's easy to remember this. Okay, I think it's quite relatively easy to remember this. I quite like the chapter of homeostasis and all the case studies because just remember one and you flip it the other way. I think there's a little bit of effort that needs to come in when you want to learn about how you can go about raising blood glucose levels, how you can go about lowering blood glucose levels. We've summarized that in the table below. These are the effects that insulin can have on your cells and glucagon can have on your cells. Yes?
Why isn't glucagon like positive feedback? Because it increases the blood glucose level, so it's like amplifying the process of releasing glucose.
Okay. I think when we look at positive feedback, you have to look at it in relation to what the original stimulus was. In this case, glucagon is increasing blood glucose levels, but it is in response to what was low. So when we define something as negative feedback, usually it is to define that the response counteracts what the original stimulus was. So the stimulus here is not that glucose is present, but that it is at low levels. So we counteract it by increasing blood glucose levels. Here, if blood glucose levels is high, secrete insulin, counteract it, bring it down. So we use negative feedback when the effect counteracts what was the stimulus. So when you look at this table, there are many different responses. May I request that you remember two of the effects? You don't need to remember all of it and commit it to heart. There are two different ways you may assess your understanding of the effects. Number one, you could write an essay. If you're asked to write an essay, can you give me at least two of the effects? Which two I think are the best? You look at the responses for insulin. Increase uptake of glucose into cells by enhancing the permeability of the cell to glucose. I think this is quite a good effect to bring up. If you want to reduce the amount of glucose within your, if you want to reduce the amount of glucose within your system, it makes more sense if we make our cells more permeable to glucose, so they can absorb more of it. I also like point number two, convert more of glucose to glycogen, which is a storage form of glucose in your body. So I would choose effects that can directly explain why glucose level increase or decrease. I find the remaining ones a little bit, perhaps, the link requires a few more steps in between. Increased uptake of amino acids, protein synthesis, fatty acid synthesis. How in the world would this relate to reducing the amount of glucose in your body, in your cells? In your bloodstream? It is complicated. There are many steps in between. So I think perhaps to memorize this may not have that much value to yourself. So focus on those examples that directly relate to how you can increase or decrease glucose. Could I still put this in MCQ? Can, it's possible. Yes.
What's the difference like between the top column and the bottom column? Like why they separate?
Let's see, increased conversion of glucose to glycogen, increased conversion of glycogen to glucose. I think what they are trying to show here is that insulin has effects that can speed things, up and can reduce the effect of. So perhaps what this table is trying to show is number one, insulin as a hormone can have many effects. Number two, they are trying to classify the effects into two categories.
Not all of them are effects.
Yeah, all of them are effects. So don't need to memorize all of the effects. I think it's about providing two good effects that can help to explain why glucose may increase or decrease in your bloodstream. You can see that they are quite different things. You increase the conversion of glucose to glycogen versus you decrease conversion of glycogen to glucose. They are different pathways. One is the forward, one is the backward. Yes. Okay, why does it increase this, is it? Okay, sometimes you may find that in other textbooks they may say insulin can help to perhaps increase metabolism in our body. Yeah? When you increase metabolism, it just means, if I summarize it, increase the amount of chemical reactions taking place in the body. Chemical reactions sometimes require energy, so that's where our glucose may end up being used. This is it trying to expand on the word metabolism. That you involve in protein synthesis, fatty acid synthesis, and so on and so forth. Yeah. Sorry. I choose, you could, but I think you choose the examples that can directly explain why glucose increase or decrease. It will be very clear for you. 4.3 came up with an interesting way of remembering, the glucagon we produce in response to low glucose levels or high glucose levels. They came up with an interesting way. So one of the students said, okay, so you will produce glucagon when the glucose is gone. Not bad, right? I thought it's not bad. So when glucose is gone, so right, if there's low glucose, then you produce glucagon. Okay? You're not very impressed. I was very impressed. Help me remember quite a bit. Take note, some students at this juncture, you have learned many words that come with G, L, and a C, and a G, and an N. For example, glycogen. Some students, right, will start to mix up all these terms together. Glycerol. Okay? So once you hit this chapter, try not to start to use these words interchangeably. They're very, very different things. Glycogen is the storage form of glucose in animals. Can you recall what's the storage form of glucose in plants? Starch. How many kinds of starch are there that you learned? Huh? 4? Where you'll get 4 wrong? 2. Both start with A. Okay, what are the two names of the starch? Amylopectin as well as amylose. Sorry, up to you whether amylose or amylose. Okay, so glycogen, this is a storage form of glucose. Glucose, glycerol. When do you last encounter the word glycerol? Okay, plus fatty acids, what do you get? Triglyceride. Triglyceride or triglyceride. Whatever helps you remember the spelling. So don't use all these words interchangeably. In this particular part, glucagon is what you want to focus on. I can see why students may use the word glycogen, because one of the effects is to convert glucose to glycogen. Yeah? So that's where you may start to use the words interchangeably. Now, we have a look. I want to draw your attention to something very interesting. We provided you the typical homeostatic control system. You can see the receptors, you can see the control center, you can see the effectors. This is a very interesting case study because while we put the receptors as the pancreas, in truth, the receptors are the same thing as the control center. So, reality, the alpha cells and the beta cells, they are receptors by themselves. Right? So when we refer to the receptors in the pancreas, what they're trying to say is all the alpha and beta cells within the pancreas, they serve as receptors. So what does that mean? If I were to zoom into one of these cells, actually I zoom into a beta cell. Here is a beta cell. Beta cell is interesting. It is able to detect the presence of a lot of glucose, and in itself, it also serves as a control center to after that secrete insulin. So the beta cells are both the receptor as well as the control center. Same for the alpha cells. They are both receptor and control center together. And if you really wanted to, therefore, when you see this nice wheel, they try to separate out for you in reality. Actually, you can box this up together. The receptor and the control center are at the same place. This is unlike your thermoreceptors. They are very far away from your control center, which is your brain. Keller, yes.
So the receptor, is it both the alpha and beta cells or both these cells?
Ah, okay. Good question. For our level, you're not expected to differentiate. But last week I was reading up some papers because I was also trying to figure out the question you just asked. Based on what I've read, I think you are right. Both the alpha and beta cells serve as receptors. From what I've read, the alpha and beta cells can also inhibit each other in certain ways based on what they detect. I'm not too clear on the full mechanism. So for our level, you do not need to know all the inhibitory effects or whether they promote each other or not. But I put it simply, yes, both cells are receptors. Are you asking, are both cells receptors for regardless of condition? Right? Okay, at least from what I read online, it would seem that yes, in the sense that they could inhibit each other based on what they detect. I also say no, because when alpha cell detects low glucose levels, it is the one that results in a response. The beta cells are not involved in the response that alpha cells will create. Okay? So I think it will be better if you differentiate them. Yes, Radisha?
So like in this case,
The
the hypothalamus
hypothalamus is?
is not involved.
Ah, okay. In this case, is the hypothalamus involved? Not really. So, while, remember, I said a lot of the control center tends to be in the brain. This is a case study where it need not require the brain. It can, the pancreas is the one that is involved producing the hormone. Okay? So this is an interesting case study. Yes?
Then when the diagram says like the receptors that stimulate, then how does it like actually stimulate the control center if they're the same thing?
How does it stimulate the control center? In other words, this cell is both receptor and control center, right? It means to say, okay, let's look at a typical homeostatic system. What we are used to is that the receptor and the control center are perhaps far away, right? And what we are used to is that the receptor may detect whatever the change is, then it may then transmit this change, the signal, to the control center. And this could be employing hormones, or it could be using nerve impulses. So now Christine's question is, if the alpha and beta cells are both receptor and control center combined into one, then how? Then we just simply skip this part. You don't need this middle part anymore, you don't need a messenger. What happens? After it gets the signal, immediately it will just produce the hormone. As though it is the control center now. Okay? So the beauty of this system now is that we skip this section. But why then did the textbook separate it out for you? So that we are still so that it shows you that at the end of the day, if we want to detect a change, we still need receptors to detect the change. To be able to therefore bring about an effect, you still need a control center to produce a hormone or maybe a nerve impulse. So this is deliberately separated out for you so that you still see the parts, even if the parts are actually connected to each other. Yes, Chen. Correct. Yishen asks, if you say the receptor is a pancreas, are you wrong? Not exactly. It's just what scale we are looking at it at. When I say the pancreas is a receptor, you're not wrong because it is made of many cells, alpha and beta cells, that serve as the receptors. You could also zoom in and say, in this scenario, the alpha cells are the receptors. In this scenario, the beta cells are the receptors, and you're not wrong either. It is the scale you're looking at it at. Are you? Oh, you say the islets are like a hands. I think you could. Okay, let me think up. I think it's okay. It's okay to say islets are like a hands. But when you want to bring up the effectors, you bring up the correct cells. Okay? Okay. So actually, if you look at it, one might think, actually this is just memory work. Right? If it's just memory work, then therefore the questions that come out, quite simple. Okay, so let me give you some variations. Perhaps someone may ask you, know someone just he visits the doctor, and then they take out a blood sample. In the blood sample, they realize that, hey, this person currently has a spike in insulin levels. Can you tell if this individual just had a heavy meal or was starving prior to the checkup? Can you tell? Can I say again? Perhaps this person just went for a health checkup. After they extract some blood sample, after they go and check what's in the blood sample, they realize that there's a spike in insulin, lots of insulin. So then the question is, do you think this person just came from the canteen, just had a very heavy meal full of starch, or that this person is starving a whole day? Right? Can tell? So this is the kind of puzzles that you're expected to be able to solve. Maybe something else. We're looking at a person's body, and we find that currently this person's body has a high amount of glycogen stored. When you work backwards, can you tell if this person just had a heavy meal or was starving prior to this? Yeah? Lots of glycogen stored in the body. Is this person starving? Or is this person just ate something quite heavy, full of sugars? Think up. This person has a lot of glycogen stored in the body. Yes?
I read that the production of insulin from the pancreas is stimulated by the intestine, which secretes another hormone, which then stimulates the insulin production. So then, is the intestine the actual receptor?
I don't think so. What is this? Is it a research paper? Okay, you can send to me because at least from what I've read, it functions along the line of even the receptor that I'm talking about. I'm simplifying things. This receptor involves a glucose transporter. If there's a lot of glucose will be entering the cell, and it will stimulate some responses as a result. So maybe there's a mechanism, another mechanism as a receptor. I'm not aware of that. At least the one I'm aware of is this glucose transporter mechanism. Is that to me? Yeah, I can look. Perhaps there are two receptors in play. Okay. So I never answered the question. So you all deduce. Okay, but let's just face it. If you are starving, right, it doesn't make sense that you still have storage of glycogen in your body. Right? Your body will have broken down the glycogen so they can feed the glucose back to your blood system. Yeah? So usually a sign that someone has starved for a very long amount of time, there's not a lot of glycogen in your body. But someone who is well fed, always eating, not starving, you would have glycogen stores. You will have glycogen stores in your body. Okay? So that is a case study that we expect you to be aware of. So far now you know 2 case studies, thermoregulation as well as blood glucose concentration. You know 2 homeostatic processes now. You will learn 2 more chapters down the road where we dissect the kidney together. Okay, and that will be the last homeostatic system that you need. Can you? Okay, why are people encouraged not to eat before a blood test? I suspect it's because they want to see what is your normal sugar, what is your basal sugar level. Okay, because if you eat right, there's a chance that whatever they are testing, it is elevated sugar level. You don't know what is your normal range. Because if you eat right before, it could be that now your sugar levels is out of range. But if you don't eat, then your body is currently fighting to keep it within that range. And I think they want to see what is your range. But if you eat right before, right, it could be out of range, right? It may take a while before it goes back to the range. So then we cannot tell what is your range. Yes?
Does it mean that only when they detect a difference in normal blood glucose levels, then insulin or glucagon is produced?
Okay, that's a good question. Shanice asks, are these responses, do they only happen when there's very high or low glucose levels? From my understanding, even right now in your system, you have a little bit of glucagon, a little bit of insulin running through your system.
So they are still producing it right now?
Yeah, so from my understanding, our body actually produces a basal, a very minimal amount of insulin and glucagon that's always flowing through. Our cells, after all, need a way to pick up glucose, be able to get its energy. It may need to put back glucose into the bloodstream. And from my understanding, there is always a basal level because our body is constantly in that flux. You will not find our body at a state where glucose level is constant. It's always in the flux. You do a simple action, you start to use a little bit of glucose. Yeah?
So there always has to be insulin and
Alright, so actually in truth, there's always insulin and glucagon, just a little bit flowing through our system. So, why are we learning this then? This is if the blood glucose levels go way below our range or way above our range. You will expect that alpha and beta cells will produce more of these hormones. It already produces these hormones, but in these severe conditions, will produce more. Okay? So it's a misconception to think that alpha cells only start producing the hormones when glucose levels are low. It's already producing. Instead, it produces more now. Okay? So I think what would be better is as an arrow. It produces more insulin, more glucagon. It doesn't start. It produces more. Yes.
After it reaches the normal level, what happens to the insulin?
Oh, okay. Santosh asks, after we reach within back the normal range of glucose levels, what happens to insulin? What do you think? Then yes.
Does it go to the liver and is destroyed?
Yeah, you're right. Okay, we need to destroy the message. If we do not destroy the message, we will continue the effect. So you're right, it needs to be destroyed. And where is it destroyed? I think the definition of hormones that you're expected to know is that they are destroyed in the liver. Go back to this part over here. Define a hormone as a chemical substance produced by a gland, carried by the blood, alters one or more target organs, and finally destroyed in the liver. So we have to destroy that. We don't just destroy. Okay, why is it destroyed in the liver? I think lower JH you may have learned that the liver helps to break down proteins. Yeah, remember that? Deamination. Remember those processes? If you don't, it's okay. Good thing we're not testing ratios. Yeah?
It's not healthy.
Shall we try a series of questions? Yes, Christine.
Is glucagon always produced after a meal?
Is glucagon always produced after a meal?
Because like what if you eat a meal, then your blood glucose level increases, but in the first place your blood glucose level was already normal. So it wasn't low, but
But we
then
produce glucagon in response to if you have low blood glucose, right? Yeah. Okay, so I'm trying to work with you. You say if we just have a meal, could glucagon level increase? Is that your question? You know, why do you think it will increase if you just have a meal?
because like isn't that when glucagon is produced?
Oh, okay. Okay, glucagon is produced in response to, okay, the effect of glucagon is to raise blood glucose levels in your blood, right? That means to say, I should produce it in response to when your blood glucose level is low. So actually, if you just have a meal, and after your body digests the food, the glucose will enter your bloodstream, your blood glucose level should raise, right? If blood glucose levels are high, I wouldn't want to produce more glucagon to result in more glucose being put into the blood. It's like if after you eat a cake, your blood glucose levels increase. Then if glucagon comes in to increase the sugar level more, it's like, yeah.
Then when is glucagon like produced? When you are hungry?
You could say so. I think when you are hungry, it is a mental signal being sent to your stomach that you have very low glucose levels. So yes, it could be being produced when you are starving to help you last until you run out of glycogen stores. Does that answer your question? Thank you. Yeah. Well, okay, tell you ask a very tough question. You just had a meal, then you go for a run. So which hormone would we be using? Let's think up. Okay, then I think there are many factors here at play. How, after you had a meal, how long do you take a break before you go for a run? Let's say you have not eaten anything, then you have the meal. You immediately go for the run. I would say when you go for the run, you are working on the basis that you have not had a meal yet. Because it takes a while to digest, right? But let's say you have the meal, then you have a break. In that break, your body could be employing this. Then you go for a run, your body's blood glucose level may dip, then you start to produce glucagon to access whatever you've been storing after the meal. So I think it depends on how long after the meal you go for a run. Yes, Zoe.
Why is it more common for people to lack insulin than glucagon?
It's a good question. I don't know. I really don't know. Yeah. Why that's the case. Usually, in biology, when we don't see something happen, it could mean that the effect is more drastic and that people die very fast out of it. So I'm not sure. I really don't know. But you got to find that. Or it could be that there is an effect. It's just that I don't know why maybe it's not very well studied. I don't know. You can Google, then maybe you can give us an answer immediately. There must be an issue, right? If we study, we will study in the next tomorrow's lesson what happens when you have too much or too little insulin. But we rarely talk about this. That's a good point. Maybe go look it up. What happens if there's an illness where we have too little glucagon? But for now, Chrissy.
Then like for diabetic patients,
Yeah.
why do they only have insulin injections? Like let's say they usually have a very low blood glucose level that like inhibits the other, like not inhibits,
Okay, I mean you see when insulin is produced. Insulin is produced when your blood glucose level is high, right? So the issue that diabetic patients face is not that the blood glucose level is too low. The real problem that diabetic patients have is when they take very sugary things, their body is not able to regulate it. I lost the question.
Because like I have seen that some diabetic patients, in general, they just have like difficulty regulating the blood glucose level.
Yeah.
And sometimes they have very low blood glucose level to the point where it's dangerous and
Okay.
they faint.
Okay, so why not inject glucagon, right? Actually, when diabetic patients have very low blood glucose levels, their response is they don't need to add more glucagon. Actually, you know what they do? They just pop a sweet in their mouth. Yeah. Okay, because their body still produces glucagon. There's no issue with their alpha cells. They still produce glucagon. I remember I had a student during exam time. If he feels that he's starting to feel very tired, usually if you feel very tired, it is one of the possibilities is that you have very low glucose in your body. So your body is feeling tired. Why? Because you need glucose for cellular respiration and get ATP for energy, right? So I noticed that when a student feels tired, he's allowed to bring sweets into the exam hall. So he'll pop out a sweet and then he'll start running. So that's his response. But if he were to take too much sugar, I think the response would be, now I need insulin. Yeah, so insulin is a response to if you have your sugar levels are high. When your sugar levels are low, it takes sweets.
But then if the alpha cells are normally producing glucagon, then why would they have like trouble regulating it that they would need to eat a sweet when other people wouldn't?
But that's a good question. I need to think this through. Why would that be the case? Why would they pop a sweet? Why would they pop a sweet? I don't know what you all think. Blood glucose level is low. Why would they pop a sweet and actually their glucose is low? I'm not sure. I'm not sure why. Ask myself. Yes, they have a possibility, yeah. Yeah. Oh, okay. Okay, this requires a little bit of knowledge. Next lesson. How you work out that actually there are two types of diabetes. It's true. One is a problem with insulin being secreted. One is a problem with the receptors. The time you suspect that perhaps the person's body does not have enough glycogen stored because insulin wasn't doing its job. Could it be? I'm not sure. I have to give you some thought.
But
Yeah.
then if they already take insulin injection, then
Yeah.
technically the insulin in the blood should be normal.
Got a point there. I don't know that. I really don't know.
I Googled
Yes,
and
what did it
it
say?
says there's like something called like insulin resistance.
Yeah, there is.
Some people can be like resistant to insulin. But then like how do they solve that? Because you can't like inject more insulin to solve your insulin resistance.
Yeah, so, okay, so did you give a solution?
Not that.
From my understanding, they still take insulin, but I think they have to take quite a bit. But it still doesn't answer the mystery of why a student might take sugar, a sweet. A diabetic patient may take sweet when they feel tired. I don't know the answer to that yet. Yes?
I also like read somewhere that like even though insulin is the only hormone that lowers the blood glucose level, glucagon isn't the only hormone that is being
Oh, I see. Okay, that doesn't help with the problem we have. Okay, maybe after tomorrow's lesson, we have a little bit more knowledge to solve this puzzle together. For now, we attempt these questions. These questions are a little bit out of the box. Requires you to think a little bit more. Questions 2, question 4, 1, question 3 and 4, and 5. Okay, can we you attempt these questions? Or maybe while you were listening to all the discussion in class, you really attempted these questions. Yes?
I also Googled like the two little one, right? And like the reason why insulin is not like prevalent is because if you don't have enough glucagon, you just die.
Also, really, it is an issue of.
It like increases the risk of brain damage or impairment, which is like a lot more drastic than so like you just die.
Right. It is better to have more glucose than to have less glucose. Right. Okay. Question 2. Here we try question 2. Which statement is false? If you rewatch videos of our teaching, right? I suggest you rewatch our class videos. Okay, if you rewatch a video of me teaching O3 and O2, there is a slight difference. Okay, the difference is that for O2, the content part will speed up a little bit, so that we have a lot more time for questions. But for O3, it is I'll go through each step very slowly, along with the videos. But they have less questions, so that's the drift I go. So if you want something more in depth, you can watch O3's video. Okay, question 2. Which statement is false? Which statement is false? Jayden? Sorry? Option 4. Insulin binds to receptors located inside target cells. Okay. Now, why might it be false? Number 1, goes back to the property of what insulin is. Insulin is a protein kind of hormone. Proteins are big, cannot pass through the hydrophobic core. Other than that, they tend to have all the hydrophilic R groups facing outwards, so cannot interact with hydrophobic core. So kind of 2 reasons why insulin binds to receptors on the cell surface membrane, not within the cell. Glucagon is also a peptide hormone. What does this mean for you? Insulin and glucagon are both protein in nature. We could ask you about their primary, secondary, tertiary structure if we want to. Okay, from your JH402 days. Thanks, Jayden. Next, if you go down over here, insulin is produced only when glucose levels are high. Shanice asked the question earlier, so we sort of answered that question. Are these hormones only produced when glucose levels are high or low? That's not true. There's always a little bit of these hormones being produced in our body to prevent it from even going out of range. What you're learning about whether you starve or whether you eat, it is to bring it back into range. But our body is always producing these hormones to prevent it from going out of range. So it will be false. It is not only produced when glucose levels are high. More will be produced when glucose levels are high. Next, which situation will cause an increase in insulin secretion? Heidi? Which option will result in an increase in insulin secretion? 3. Yeah, okay, so doable, right? So the variations of questions you may encounter really just plays along the lines of at what point of this homeostatic control system I want you to be aware of. Yes.
But then it's an option 2 also, right?
Onset of puberty.
Yeah. Because I read on Google.
What do you read?
on Google that during puberty or teenager will generally experience an increase in blood sugar.
Oh.
Yeah.
No,
but actually I saw it on Google.
But is it the role of insulin to reduce blood sugar levels in your system?
Yeah, so if there's an increase in blood sugar, then it
Oh.
will like produce more insulin.
Oh, well, I think that's not what they meant. I think what they're saying is that when you are a teenager, your range of what is healthy now increases. Yeah. Not you're in a constant struggle. I think what they mean is that your range is now higher. Perhaps it's because your body needs more sugar, so now they've shifted the healthy range to a higher range, so that you have inherently more sugar flowing to you when you're young.
But if you need more sugar, then you need more insulin.
Oh, the basal level of it, is it? Oh, okay. Fair enough. Fair enough. Wow, fair enough. Okay, you might go whether when you have puberty, do you have more insulin produced? Yes, then wow, okay, good. Question 4, doable. Excess glucose will be stored in the liver as? Yeah, just to mix up the words. The only function of this question is to check your spelling. Last question, question 5. What will happen to liver insulin when blood glucose levels return to normal? And Santosh asked that question earlier on. Yeah? Okay, so Santosh has helped answer that question. Yes, what do you find out anything, Zoe?
Okay, so apparently puberty causes like insulin resistance. So if it causes insulin resistance, then don't you need more insulin to counter that?
Wait, no, if you say that puberty causes insulin resistance, that explains what just he said. That now your blood glucose levels are inherently a bit higher. Interesting. Then the question is really why at puberty do you need more sugars? I think it's likely because at puberty you're growing, you need more. Yes?
Does drinking water make you produce more glucagon? Because when you drink more water, then the blood,
Becomes
like the concentration.
right? Okay. I was thinking about that. I think that may happen if you drink a lot. So I think to really get your concentration out of whack, right, you need to drink a lot of water. But I don't really talk about how much water affects your blood glucose concentration. I don't know why. But I think if you drink a lot, it could affect. Okay? So, the remaining time, let's do some practice to make some progress. We try question 1 and 2. I think they're all quite doable. Those that are done and bored, you go and I recently I found out that food coma is related to what we just learned. Your food coma, after a heavy meal, you can come back to class, right? It's impossible to stay awake. It's related to blood glucose regulation. You can go and read up on it once you're done. It's very interesting. There's a way you can prevent food coma. Now it's posted. the cell is a receptor itself, and it's going to produce a actually there is no direct. So actually only the endocrine system seems at the juncture where insulin or glucagon is produced to the the last question, number 3, is an essay. There's a sample of kind of essay that can come out. As a receptor, because factually, yes. Some students will give other points. So on this answer, you will find that show give many points. So that
Yeah, the one that we did. Come on.
personally choose the two that directly explain why the is sufficient. In the sample answer that's provided, they may have given more points as a buffer. Some students may choose to use this point, some that point, just to cater for the variation in your answer. But if you scared your 2 points are not correct, you just need one more.
change essay. Yeah, which background?
It's not change his background, it's not very much. That was the one that raised it up kids.
Actually, the whole thing. Oh, yeah.
Okay, let's just go through the first two questions. I will not really go through the essay. I just want to show you a sample of it. Question 1. Which is the correct option? And this is just another way we can ask you and test your understanding. Okay, question 1. What will be the answer? Is Xiang? Question 1. Okay, a high glucose content in the diet will lead to an increased production of glycogen in liver cells. Okay? Stands up. He asks you to state where insulin receptors are found and explain why. Some key vocabulary I think you may use in this answer. Manu? What do you write? I'll just extract out the vocabulary. Yeah? Okay, surface of beta cells. Wow, okay, this is very specific. Very good. Okay, Manu mentioned the specific cell. Okay, then the question is, the question is insulin receptors. Where are insulin receptors found? Beta cells produce insulin, right? Okay. If beta cells are the ones that produce insulin, that means insulin will need to bind to another effector cell. So the receptors cannot be on beta cells, right? Make sense? You're saying that the insulin receptors should be found on the beta cells. And the beta cells are the ones that produce insulin. The insulin receptor should be on target cells of the effectors. Yeah? If you have insulin receptors on beta cells, it's like you nail your cell and then you put it back in the home mailbox. Okay, so not beta cells, it should be found on the target cells. If you say surface, we could elaborate on that. That would be, where will it be on the surface? The cell membrane. Yeah? So, you will be more specific, the cell membrane. Anything else? Okay, then explain why. Okay, so let's build on Manu's point. Manu says the receptors should be found in the cell membrane. Explain why. I think we explained a bit just now. Pani? Okay, let's listen. Listen. Okay, sorry, Wani. Okay, peptide hormone. Next. Okay, thank you. Therefore, it's water soluble. Anything else? Okay. Wani also mentioned the size. Okay. So these are some vocabulary you could use. Other than water soluble, some of you may have used the word hydrophilic. Are groups of the proteins. Other than that, if you want to throw in the word hydrophobic form of the phospholipid bilayer. This is what you cannot pass through. Okay? So these are some vocabulary they want to include inside your sample of an essay. I show you this one sample because the other essay would be a flip of this. Okay? When blood glucose level rises after a heavy meal. It's another variation of an essay. Decreases after you starve yourself. Yeah? So two variations of this essay.
What are you saying?
In this last 5 minutes, if you like to, and I cannot answer your questions, you could hand out some questions for me, or for the class, we can try together, and we can answer some questions in the remaining time. Wow, yeah. So a lot of these questions. Zoe, I think Zoe researched this just now. Have, right? Have, but okay. But the problem is that such people, the consequence. Okay, the symptoms are very drastic, as Zoe said. So perhaps that's why we don't see many patients because they may not live without it. Is that along those lines, right? Okay. This question has to be answered, or is it something new?
Oh God.
Long, huh?
Wait, when did you Wait, someone asked a question on YouTube.
Recently, at least to what I'm aware, I think diabetic patients, they still can digest food quite normally. So I think the exocrine functions are not really impaired. So endocrine ones at the same. I thought you asked, when do we know if we need to know? Yeah? When do we know if we need to know that we need to about too much glucose is being converted to glycogen after high intake sugar? Shut try again. What's your question? Sometimes what's your question?
So after it goes like, what if it goes below the normal range of
Yeah?
what if it goes below the normal range of the glucose concentration?
Okay, and then?
Yeah, that's the question. Like this secretion of insulin, right?
Yeah.
What if there's too much insulin and there's too much glycogen converted to glycogen? Then what happens? If it goes below the, you need to know.
Okay, when does glucose get converted to glycogen? When you have insulin, right? Okay.
So when there's too much glycogen is converted, right?
Oh, okay. So if you find that the liver has a lot of glycogen, very likely there was insulin present that resulted in it. Does that answer the question?
Yeah, but when do we need, like, in the question, like, they ask what happens after a high intake sugar, right?
Yeah.
And we need to say that glycogen is produced if there's too much of
Well, actually, if you have a meal and there's a lot of sugar in the system, insulin should be produced to result in this effect. I'm not answering your question because I don't know what your question is. Can you text me when you but I think we mismatched now. Your receptor and my hormone are not connecting. Ife asks, okay, let's say Ife's question. What are some examples of endocrine diseases caused by overproduction of a certain hormone? At least to what I'm aware of, I mean you may have seen some cases where some human beings are extremely tall. That could be a result of too much growth hormone being produced. Yeah? So that's one example. I think that's quite visible. Too much growth hormone produced by the thyroid. Then they grow very fast. Okay, it's 9:30. anyone really felt was